Hey, physical science, it's Wednesday, the 29th of April, and we're going to go ahead and take a look at Statue of Liberty again on page 552. Did you guys bring this with you? I hope so. You're going to be needing it. Now, the Statue of Liberty has that green coating on it called patina, which is copper sulfate protection of that copper. I once had a house in California that I had to sell while I was in the Navy because we were being transferred. And it had lovely copper elevation roof line above the front doorstep. And they had turned green. It had turned green, that flashing. And so I went up there and I used vinegar and salt. Some would say lemon juice and salt. We'll take that off. And it got nice and pretty. And I sold the house, and I'm sure it's green again. Okay, I just thought I'd tell you. Page 554. We're talking about chemical bond formation. And the only way to do this is to talk about lithium fluoride. Let's combine lithium with fluorine. We got lithium, solid, that's a metal. And we got fluorine, which is a diatomic element, and it's a gas, and it forms lithium fluoride, which is a solid. Now, what we're going to have here is one atom of that, one atom of that, two atoms of that, two atoms. You don't have to, well, let me just go ahead and show you. Put a 2 there. That way we got 2 of those and 2 of those, got 2 of those, and now we got 2 of those. That's a properly balanced chemical formula. And how does that happen? Well, the lithium right here looks like this. Let's draw an atom. If you've got notes, and I hope you do, draw me a lithium atom. What kind of lithium? Well, let's just see what most lithiums are. Lithium, let's make it weigh 7, because that's the common mass. So a lithium that weighs 7 atom would have 3 protons because the atomic number is 3. And if it weighs 7, it's got 4 neutrons. That's the nucleus. If it has 3 positives, then it needs 3 negatives. There's an electron, here's an electron, and on the second energy level, we have another electron. Now let's go ahead and draw a fluorine atom. Draw one, F-L-U-O-R-I-N-E. Not flour, but fluor. Fluorine is element number 9, but more importantly, it is, let's draw one that weighs 19. That's pretty common. It's element 9, so we got 9 protons. If it weighs 19, that means we've got 10 neutrons. You getting this? All right. And then we're going to go ahead and surround this with 9 electrons. The first 2 go on the first energy level because that's all it can hold. And the next energy level has another 7 because 7 and 2 make 9. 1, 2, 3, 4, 5, 6, 7. Okay? Now, why does it form a compound? Lithium fluoride, LiF. Why does it do that? It's because lithium has one what I call dangling electron. You see this electron right here? It doesn't want to be there. It is electrically neutral, 3 positives, 3 negatives, electrically neutral, but it's unstable as an atom. You see, in nature, elements do not normally exist in their elemental form. They exist in compound form. And the reason they don't exist in elemental form is because atoms of elements are typically unstable. What does unstable mean? it means the outer energy level does not have a stable octet. How many does ocho mean? 8. A stable octet of electrons. Or we might call it a stable duo of electrons. Duo means 2. How could this have 2 electrons on its outermost energy level? Well, by getting rid of this one. Where does it go? It goes into empty space. Particularly if there's one nearby that needs an electron, it will go into empty space and get sucked in right here. And that's what happens when lithium gets near fluorine. Lithium wants to shuck off an electron and fluorine wants to pull one in. And that's called ionic bonding because they form ions. What are ions? Ions are charged particles. And so how do compounds form? They form by transferring electrons. That would be losing or gaining. Losing electrons, metals are losers. Metals are losers. Lithium is a metal. It's one of these blue things. Most of the periodic table are elements that are metals. They're shiny, they're good conductors, they have malleability and that kind of thing. Non-metals, there's not as many. There's only a few. Those are yellow. And that's what fluorine is. It's one of these non-metals. So if you take something from over here and you take something from over there, the metals are going to lose electrons to make the outer energy level stable, and the non-metals are going to gain electrons to make the outer energy level stable. What is the definition of stability? It means that it has an octet of electrons where? In the outermost energy level, or a duo of electrons in the outermost energy level. And do you know why it needs to have an octet or a duo? It's because that's what the noble gases have. The noble gases have either 2 or 8 electrons in the outermost energy level. If it's helium, it has 2, and all the rest of them have 8. It wants to be like a noble gas on the outside. But in doing so, it no longer is neutral. The metals tend to be neutral as atoms, but unstable. This is neutral and unstable. What do you mean unstable? It's unstable because it only has 7 electrons in its outermost energy level. I thought it had 9. Yeah, the first 2 are buried down deep, and the other 7 are on the second energy level, the outermost energy level. So these are neutral, 9 protons, 9 electrons, but they're unstable. How do they gain stability? By gaining an electron. So now it's no longer neutral. Now you have 10 electrons. You have 10 electrons and negatives and only 9 positives. What is negative 10 plus positive 9? Isn't it negative 1? So this fluorine atom becomes a fluorine ion. And the symbol is brackets with a negative 1 next to it. That's because it has one more negative. Like some people go like this, 1 negative. It has 1 more electron than it has protons. So what happens over here when it loses that electron? Well, now it has 2 negatives and 3 positives. What is -2 and +3? Isn't it +1? So it becomes a lithium ion of charge +1. Why 1 positive? It means it has one more positive, one more proton than it has electrons. Why? Because it lost an electron. So now it's no longer neutral. It's an atom with a buzz called an ion. So it's charged. And it's no longer unstable. It's stable because it has 2 electrons on the outermost energy level, because that second energy level doesn't exist anymore. This over here is stable also. And by the way, when it has 2 on the outermost, it looks just like neon on the outside. Oh wait, helium on the outside. That's element number 2. Now when fluorine gains a 10th electron, what's element number 10? It looks like neon on the outside. The electrons are similar to the way it is with neon. So it's not neutral anymore, it's charged. And it is stable. Charged and stable. And that's a fluorine ion. And this is a lithium ion. And the fluorine ion is normally called fluoride. And what do opposites do, guys? Opposites attract, right? So this positive ion over here and that negative ion over there, they get together and they form lithium fluoride. So what holds atoms together? It's electrons that have been, it's a force. It's a force that holds them together because atoms are either lost or shared. Lost or gained or shared. And we're going to talk about how they can be shared next time. So this is called an ionic bond because it's formed from ions. And metals are losers of electrons, and they form positive ions. Non-metals are gainers of electrons, and they form negative ions. And opposites attract, and boom, that force, electrical charge, holds them together in that particular compound.